My name is Tom Zort, and this is my explanation video for Assignment 4, an Intro to Neural Networks. This is on convolutional neural networks. So first thing we want to do is import all of these required packages, which you can see we do here. Then the next thing we want to do is load the data set and put it into the different xtrain, ytrain, xtest, ytest. So you can see we do that here, automatically puts it into these two. Got xtrain, ytrain, xtest, ytest. And then we show the shape of these, which you can see down here. And then also it says to set some variables. So we set the batch size to 128, which it says to do up here. Set the epochs to 1 down here, and we do the num classes to 10. So, yeah. And then next thing we want to do, this was code that was given to us, so we just paste this in here, gives the image rows, columns, reshape some stuff, makes it easier for us to do some analysis, and now we can see the new shape is 2828.1. Then the next thing was also this bit of code was given to us. Put that in right here. This shows us an example of some of the inputs that are being put in. So as you can see, this kind of looks like a 5. Then we have the label as it's 5, 9, 9. This is what the neural network is seeing. This is what the label is for that. Then next thing we want to do is normalize the input. So we get the xtrain in between 0 and 1, which tells us to do here. And then we're dividing by 255, because the RGB values are 255. So if you divide by 255, then you're going to get a number between 0 and 1, which makes it easier for us to do analysis on. And then we convert the vectors into binary matrices with this Keras function right here. We do this for all the y values. And then our data is looking good. So then we need to actually build our convolutional neural network. So the first layer, 32 filters right here, 2D convolutional network, 3x3, just say right here, with ReLU. And then we put in the input shape as the input shape. And the second layer has 64, and it's 3x3, so you can see the second layer, 64 here, 3x3, and it's also a ReLU activation. Then we want a max polling 2x2. It's this piece of code right here. We want to drop out a quarter of them. So we do that here. We then flatten it. We then do a dense layer with 128 nodes and a ReLU activation, which is set up here. Then we do another 25% dropout, and then we add the final dense layer with the number of classes as the number of nodes and the activation of softmax. And then we do this model summary, which just kind of shows us all of that in a more convenient way. Now what we want to do is train the convolutional neural network. So we compile it with all of these up here. So we set the loss to this. Do here, the optimizer to Atom, and the matrices, or the metrics, to accuracy. And then we fit the data. So this is where we're actually training it. We put in the xtrain, the ytrain, the batch size, the epochs, and then the validation data is the test data. This just validates that it's working. And then we get the score by evaluating it. And as we can see, the score accuracy was 98%. So that's how we build our first convolutional neural network. Then if we want to save it, all we do is model.save, name it, load it the same way, model load, and then the same thing that we saved it as. And then we can put more test values in and print the accuracy, as we see here, without having to retrain the network, which makes it convenient so you can share it with other people and they don't have to spend the 10 minutes that it takes to train the network. And yeah, that's been assignment 4, convolutional neural networks.